Hello everybody, welcome to Golden Career Classes. Today we will discuss time and work, pipes and cisterns. Just because we have been continuously asked for English videos, so I'll do this video in English also. So pipes and cisterns time and work topic basically considers the topic where if we have a tank which has say two inlets and one outlet. So if the tank is getting water or any liquid from one of the from two sources, and one of the sources is letting it out, so in what time will the tank be filled, or in what time will all the water be drained, depending upon the rate in which the water is flowing in or flowing out. So we will discuss few questions related to this topic, and we'll use some tricks to solve these questions. Tricks are basically, it is basically a method which will help you in solving these questions a bit faster than you would do if you followed the conventional method. So our first question is: a pump can fill a tank with water in 2 hours because of a leak. It took 2 hours 20 minutes to fill the tank. This is wrong. So the leak can drain all the water of the tank in. So in this question we have been asked in what time the leak will drain all of the water from the tank. So first, if we consider the pump as A and the leak as B, that leakage which is caused, which is letting the water out, is considered B. So what we have been provided in this question is that the time which A requires to fill the tank, that is 2 hours. And next what we have been provided is, the next thing which we have been provided is that if both the pump and the leak are working together, that if the tank is being also filled and the water is also being drained, that time is also given. So what we are given is A plus B, that is the work of the pump as well as the leakage is also given. So their combination is given, not only one of these, only the pump efficiency not time of the pump is given, and the combined work of pump and the leakage is given. So if the leakage is if with the leakage it is requiring 2 hours 20 minutes to fill the tank. 2 hours and 20 minutes. 2 hours plus 20 minutes means 1 by 3 hour, that is 20 by 60. So it's 1 by 3 hour. So what we get is 7 by 3 hour. Now we will take the LCM of the time required by A and A plus B. Let's see what we are going to do now. A is 2 hour, A plus B is 7 by 3 hour. We will take LCM of these two times. It will give 14. LCM of these two will be 14. How can we calculate the LCM of fractions? So what we have is 2 by 1 and 7 by 3. So what the LCM of these two number will be LCM of the numerator divided by HCF of the denominators. So LCM of the numerator, which is 2 and 7, is 14, and the highest common factor, which is HCF of 1 and 3, is 1. What we get is 14. Here it is LCM. Then what here the LCM represents? LCM here represents the total unit of volume which they are filling or draining, whatever. So 14 here will be the total number of units of, we can say work here because they are doing work, so filling the tank is a work. So here we can say that 14 is a unit of work or volume, whatever. Now we will calculate the efficiency of both of these. Efficiency is basically the rate of their work. So if A is requiring 2 hours to do the whole work and whole work is 14, then the work which it is doing in 2 hours, the work which it is doing in 1 hour will be its efficiency. So work per hour or units of volume per hour will be their efficiency. So how can we calculate the efficiency? Efficiency will be the LCM of time which we have. This time LCM is 14, LCM by time, it will be efficiency. So efficiency of A will be 14 by 2, which is 7, and we have been given the combined time of A and B. So we will find the efficiency of combined efficiency of A and B. Here we have 14 upon time is 7 by 3. Here we have 6 units per hour. So efficiency of B, we can calculate the efficiency of B if we subtract this from this. So efficiency of B is equal to 6 units per hour minus 7 units per hour. So here we have minus 1 unit per hour. Here minus, here negative sign represents the drainage, that B is draining the water out from the tank. So here negative sign represents drainage. We are only worried about the magnitude. So with the magnitude we can calculate the time it will take to drain out all the water from the tank. So how can we calculate time? So time equals to LCM divided by efficiency. So LCM is 14 and our efficiency is 1. We are only taking the magnitude because time can never be negative, and here negative is only representing the drainage. If filling the tank is positive, then drainage should be negative. So here time is 14 by 1 hour, which is 14 hour. So moving further, we have second question. It is similar to the first question. So pipe A usually fills a tank in 2 hours. So A fills the tank in 2 hours. On account of a leak at the bottom of the tank, it takes pipe A 30 more minutes to fill the tank. So if A is filling the water and B is draining the water out, so in that case we require 30 more minutes. If only A was working, we needed 2 hours. Now we are needing 30 more minutes. So we are requiring here 2.5 hours of time for A and B combined. So their LCM will be 5. So this amount of work both A and B have to do. So efficiency of A. Efficiency of A will be 5 by 2, which is 2.5, and efficiency of B will be 5 by 2.5, which is equal to 2. How long will the leak take to empty a full tank of pipe if pipe A is shut? So if the tank is full, how much time will B take to drain all of the water? So if we have the efficiency of B, that is the amount of work which it does per hour, if we have that efficiency, so we can find out how much time it will require to drain all the 5 unit, to do all 5 unit of work. If we have the amount of work which it does in an hour. So similarly, as we have done previously, we will calculate the efficiency. So we have calculated the efficiency of both A and combination of A and B. Now we will calculate from these efficiency of only B. So from the efficiency of A and B combined, if we subtract the efficiency of A, then we will get efficiency of B. So efficiency of B equals to 2, this 2, A plus B, minus efficiency of A, which is 2.5. So here the efficiency is minus 0.5, minus represents drainage or leakage, whatever. So time it will require, time required by B to empty the tank will be equal to how much amount of work it has to do, 5 unit, and what is its efficiency, 0.5 unit per hour. So time will be 5 unit divided by 0.5 unit per hour, which will be 10 hours. Then time will be 10 hours. So it will require 10 hours to empty the tank. Going to question number 3. 3 pipes A, B and C can fill a tank from empty to full in 30, 20 and 10 minutes respectively. So A requires 30 minutes, B requires 20 minutes, whereas C requires 10 minutes. So total number of unit of work they have to do is, the amount of work they have to do is, will be equal to the LCM of these three. So LCM will be here 60. So they have to do 60 unit of work. Now we will read the question further. When the tank is empty, all the 3 pipes are opened. Okay, we have nothing in the tank. Now all the 3 pipes are opened. A, B and C discharge chemical solutions P, Q and R respectively. Okay, in the tank A discharges P, B discharges Q and C discharges R. What is the proportion of R in the solution of solution R in the liquid in the tank after 3 minutes? Okay, we can do this. First we will calculate efficiency of A, B and C. Then we will get the amount of work they do in each minute. So if we get the work they do in 1 minute, so we can also find the work which they do in 3 minutes. So efficiency is basically the work which they do in a particular unit of time or per unit time. So efficiency of A equals to 60 by 30, which is equals to 2. B will be 60 by 20, which is equal to 3, and C will be 60 by 10, which is equal to 6. So the unit of efficiency will be unit per hour. Sorry, here we have minute. Unit per minute. So we have the amount of work they do in 1 minute. Now what is the proportion of solution R in 3 minutes? Okay, in 1 minute A discharges 2 units of P, B discharges 3 units of Q and C discharges 6 units of R in 1 minute. So in 3 minutes they will discharge 3 times of this. In 3 minutes in the solution there will be 2 into 3 units of P for A. For B we will have 3 into 3 units of Q and for C we will have 6 into 3 unit of R. So here we have 6 units of P, 9 units of Q and 18 units of R. So total unit which we have from A and B, C will be their sum. It will be equal to 33 units. So what we have to calculate is proportion of the solution R in the liquid. So after 3 minutes, the amount of R in the solution is 18 parts of 33. This will be the proportion, which will be equal to 6 by 11. So total amount of work or volume, whatever, it is 33 units, and out of this 32 or 33 units, 18 is R. So for the proportion is basically the fraction or amount of R in the solution. So we have 18 by 33, which will be equal to 16 by 11. In the similar way, we could also calculate for A and B, which is for P it will be, the fraction will be 6 by 33, and for Q it will be 9 by 33. Moving on to next question. Pipes A and B can fill a tank in 5 and 6 hours respectively. Okay, A can fill the tank in 5 hours, B can fill the tank in 6 hours. Pipe C can empty the tank in 12 hours. So C requires 12 hours. So their LCM will be 60. So they have to do 60 unit of work. Total amount of work will be 60 unit. If all the 3 pipes are opened together, then the tank will be filled in. Okay, the time required for the tank to fill in will be. So now we calculate the efficiency. Efficiency of A will be 60 by 5, which is equal to 12. For B it will be 60 by 6, which is 10. For C it will be 60 by 12, sorry, minus 60 by 12, which will be equal to 5 unit per hour, unit per hour, unit per hour. Here negative sign, we have used negative sign for C because it is given that pipe C can empty it in 12 hours. So pipe C is draining water out of the tank, so we are using negative sign. So combined efficiency of A, B and C, that is if all 3 of them are working together, so the amount of work they will do in 1 hour, because we have efficiency in per hour, so the work they are doing in each hour. So in A plus B plus C will be 12 plus 10 minus 5, because he is draining the water out of the tank. Here we have 17 units per hour. So now we have to calculate if all the 3 pipes are opened together, the tank will be filled in. So we are asked about the time. So time here will be our total amount of work which we have to do, which is the LCM of all the 3 times, 60 unit upon the efficiency, the combined efficiency of A, B and C, because they are working all together, divided by 17 unit per hour, which is equal to 3 whole 9 by 17 hour. Here is the answer. So moving on to our last question. Two pipes A and B can fill a cistern in 37.5 hours and 45 minutes respectively. So the amount of work they have to do will be equal to their LCM. So for the LCM I will write their multiplicative form and we will not multiply it, because in further calculations we will manage and multiplication will not be required. Both pipes are opened. Cistern will be filled in just half an hour if B is turned off after. Okay, it is given that the cistern will be filled in half an hour. So the time which we require to fill the cistern is already given. So what we have been asked is at what time we should turn off B so that the cistern gets filled in half an hour. First both the pipes are working together. After that B is turned off and A is started. Only A is working. It's just like for other time and work questions, as we did, that two people were working together, then one backed out and only one person left was working. It is the same type of question, just it is two pipes working together. So the total amount of work which they have to do is LCM 37.5 into 45 unit of work. So now for efficiency of A, now we will calculate the efficiency. Efficiency of A will be the LCM upon 37.5, which will be equal to 45 unit per minute, and for B it will be LCM upon 45, which is equal to 37.5 unit per minute. Okay, let's say that A and B work together like both of them are filling water in the cistern together for X minutes. So after X minutes B is turned off. So B is turned off after X minutes. After turning off B, only A is working. So only A works for 30 minus X minutes. So if we have the work done by A plus B in X minutes and work done by A in 30 minus X minutes, and we add them up, that work will be equal to the total amount of work which we have to do, that LCM. So we will do the same thing. We will make the equation like this. So efficiency of A, that is the work done by A in 1 minute. If we have that, we multiply it with time, then we will get the work done by A. So work done by A will be 45 efficiency of A into X plus work done by time of A will be 30 minus X. 45 into 30 minus X plus work done by A and B together. So combined efficiency of A plus B will be, combined efficiency of A and B will be 45 plus 37.5 unit per hour, minute. So A and B work together for X minutes. So if we multiply it with X, we will get the amount of work done by A and B. So here the work done by A and B will be 45 plus 37.5 whole of it multiplied by X. This whole combination of work will be equal to the total amount of work, which is the LCM over here. So here we have 37.5 into 45. So we need to solve it. Solving the rest of the question over here. We have 37.5x is equal to 37.5 into 45 minus 45 into 30. Taking this to the other side of the equation, so x will be equal to 45 into 7.5. While solving this, we can easily get this. So here we have 9 minutes. So after 9 minutes, B is turned off. So A and B work together for 9 minutes, and rest of the 21 minutes only A works for the cistern to fill. So here we are done with all the questions. For further videos, please stay tuned and watch our videos. Please subscribe, share our videos, tell your friends that we are making some efforts to help you. So doing the same video in 2 languages is a very difficult task, but we are trying to do and give our best to you, and we hope that you do well in your exams and our videos will be helpful to you. So thank you for watching. Please subscribe, share our videos and like us. Thank you. And if you have any doubt, please feel free to comment and ask us. We will definitely reply and help so that we may clear your doubts. Thank you and all the best for your exams.